this video, we'll go over multiplying polynomials. We are to multiply the binomial 4t minus 5 and the trinomial 3t to the second power minus 2t plus 7. One way to do that is to set it up this way, like you did in elementary school, and then multiply. We get negative 15t to the second plus 10t minus 35 when we take negative 5 here, the minus 5, times each one of these here. Essentially, we're distributing. The next line, we have 4t times each of the terms here, 3t squared minus 2t plus 7. And notice what we're doing is lining up like terms. Now we combine our like terms and get 12t to the third power minus 2t squared plus 38t minus 35. Find the product of 7y plus 3 and 4y minus 5. Here we're just simply distributing. So 7y times 4y, 7y times this negative 5, 3 times 4y, and 3 times negative 5. Combine your like terms and we get 28y to the second power minus 23y minus 15. Here's another example of distribution. 6p times 6p plus 6p times negative 11 plus 11 times 6p plus 11 times negative 11. And these middle terms here end up canceling each other out. So we have 36p to the second power minus 121. Find the product of x to the third power times 2x minus 5 times 2x plus 5. Well, first, you ought to multiply the two binomials together. So we've distributed the 2x, 2x times 2x, 2x times 5. We'll distribute the minus 5 and combine our like terms. And now we're going to distribute the x to the third power. So x to the third power times 4x to the second power times negative 25 gives us 4x to the fifth power minus 25x to the third power. We've got another product. This is known as the difference of squares, where you're multiplying the difference of squares, or what we'll end up with is the difference of squares. What we'll end up here is also a difference of squares. And that's because in one binomial we're adding, and in the other binomial we're subtracting, but we're adding, subtracting the same thing. 8z plus 3 squared is often incorrectly calculated to be 64z to the second plus 9. Don't forget that squared means 8z plus 3 times 8z plus 3. 5z minus 12q to the third power means 5z minus 12q to the third power times 5z minus 12q to the third power. Now this product here, you can do this in a couple of ways. So here's one way to do this. If you notice, this is actually the sum and difference of the same terms. I've got 4x minus 3 added to 7y and 4x minus 3 subtracted to 7y. So I can multiply this in a very similar way to what we saw in the previous examples. Now I do still need to go ahead and do 4x minus 3 to the second power and 7y to the second power. Remember that 4x minus 3 to the second power means 4x minus 3 times 4x minus 3. Now here's an alternate way to do this. You can set this up in a box. So I've taken the first trinomial, 4x minus 3 plus 7y, and I put it across the top of the box. 4x gets its own column, the minus 3 and the plus 7y also each get their own column. And then down the side here, I've written the 4x, the minus 3, and the minus 7. Now I multiply to fill in the box. 4x times 4x is 16x squared. 4x times this negative 3 is a negative 12x. 4x times 7y is 28xy. And I do that for all the terms until the box is filled in. Now what you'll notice is that it's fairly easy to see the like terms. There are no other terms like 16x squared. these two negative 12x's will need to be combined. This negative 28xy and positive 28xy, those are like terms, but they cancel each other out, as do the negative 21y and the positive 21y. So our final answer is 16x to the second power minus 24x plus 9 minus 49y squared. Here's another example. S plus 4t to the third power just means s plus 4t times itself 3 times. So they've set this up as s plus 4t squared, which again is s plus 4t times s plus 4t. When we multiply that, here's what we get over here in blue. And we still need to multiply this by s plus 4t. If we set this up using a box, like we did on the previous example, I think it's easy to see the like terms that need to be combined. S times s squared, s times 8st, s times 16t squared, 4t times s squared, 4t times 8st, and 4t times 16t to the second power. You can see there are some like terms here, so I'm going to end up getting 12s to the second power t. There's some like terms here. I'll end up getting 48st to the second power for a final answer of s to the third power plus 12st s squared t plus 48st squared plus 64st to the third power.